Hello everybody and welcome back to another Galaxy Administrators training tutorial. My name is Simon Gladmann and I'm from the University of Melbourne in Australia, and I am also one of the administrators of Galaxy Australia. And in this session we're going to be talking about using Singularity to run Galaxy jobs for us in containers. Okay, let's get on with it. So hopefully everybody has already completed the installing Galaxy with Ansible tutorial. If you haven't, then you'll need to go and do that first, because we are going to be extending that tutorial here to include the Singularity components. Okay, anyway, hopefully everyone can see this website. It's training.galaxyproject.org. This is where I am now. I'm going to go to the Galaxy server administration part. And then, as you can see here, here's the Galaxy installation with Ansible, which is hopefully the tutorial you've already completed. And then all the way down here, we find one that says, use Singularity containers for running Galaxy jobs. And it's the one we're going to be working on today. So I'll click on the hands-on component and it opens it up. Okay, so this tutorial was written by Torfin Noem, Marius Vandenbeek, Matthias Berndt, and Helena Rasch. In this tutorial, we will be learning how to configure Galaxy to run jobs using Singularity containers. Now, the Singularity containers that we use come from the biocontainers community. So what is biocontainers? Well, it's a giant repository of Singularity containers for bioinformatic tools that are freely available for anyone to use. It's a community-driven project. And it provides a lot of infrastructure and a lot of guidelines on how to create, manage, and distribute bioinformatics packages for Singularity and Docker containers. So basically what happens is biocontainers takes anything that's put into Bioconda and then will automatically create Docker and Singularity containers for it. And if you're interested, you can click on this link here and it will take you to a website that talks about what biocontainers is and what its goals are, how it all works, and everything. It's actually pretty good. What is Singularity, you might ask? Well, Singularity is an alternative to Docker containers. Singularity containers have a couple of advantages over Docker containers in the fact that they don't use a root daemon to run. One of the issues that we have with Docker containers, especially in HPC and cluster type compute environments or multi-user compute environments, is that the Docker daemon runs as root. And obviously anyone who runs a Docker container needs access to the Docker daemon, and it may allow users of Docker containers to execute code as root on the host system, which is a terrible idea in many times. However, Singularity does not run a root daemon, and so it doesn't allow users to run any code as root. And it actually provides much better isolation and is much preferred in the HPC and cloud cluster communities for running containers. And the reason that we would like to use Singularity to run tools for us in Galaxy is reproducibility. At the moment, most Galaxy servers run Conda environments for their tool resolution. So if you want to run, say, BWA or Procker or any other Galaxy tool, Galaxy will take your tool request and then try and resolve, i.e. try and find that tool using Conda. And if necessary, it will download the Conda environment, install it, and then run the tool within that Conda sandbox environment for you. And this is wonderful, and it's been a revelation for us in the Galaxy community over the last few years. However, there are some issues with using Conda in the fact that sometimes Conda packages are updated and dependencies are updated. And so this can lead to slight changes in the reproducibility of those particular tools. And sometimes you may install BWA 0.7.15 However, somebody updated one of its dependencies the day before or something, and so it will install a new dependency. And so you may not get exactly the same version or exactly the same behavior out of BWA that you would have got the day before. And so one of the ways to get around this is to take everything, pre-build it into a container. So take the tool, all of its dependencies, pre-build it into a container, like a Docker container, and then use that instead. But instead of using Docker, we're going to use Singularity here. And this will allow for us to always be reproducible, because if we ask for the BWA 0.7.15 version 1 Singularity container, that's the one we're going to get. And it's always going to have the correct dependencies installed. It's always going to have the same. It's going to be the same forever, because all of these Singularity containers are hosted at biocontainers for us. And we can just pull them down anytime we wish. Okay, so we do need to make some changes to our Galaxy server to allow it to talk to Singularity. At the moment, every time we try and run a job, it will use Conda environments, as I said before, but we want to tell our Galaxy to use Singularity containers instead. But the first thing we need to do is actually install Singularity on their machines. So I'm going to do that now. Okay, so we're going to install Singularity onto our Galaxy server using Ansible, just like we have for everything else. Unfortunately, there isn't currently a Ubuntu package to install Singularity for us, so it's a little bit more complicated, and we're going to use an Ansible role, actually a couple of Ansible roles, to install Singularity for us and configure it. And the two roles we're going to use are Cyverse-Ansible Singularity, so in other words, a Singularity role from Cyverse Ansible. And we also have to install the Go language, because Singularity is written in Go, and we're going to use GAT-Sign's repo for that. So the first thing we need to do is open up our requirements file in our Ansible system and add these two Ansible roles into our system. So I'm going to do that now. I have a terminal open. I'm going to SSH to my machine. SSH Ubuntu at mine's GAT8. Yours will be something different. .oz.train.galaxy project. Okay, so I've logged into my system and I will do a long list, and you can see here I have my Galaxy setup, which has my Ansible in it. So I'll change directory to that. Here it is. You can see here I have my Ansible config, my Galaxy YAML file, my playbook, my group vars, my hosts, etc., roles, and my requirements file. So the first thing I need to do is add the two new roles to my requirements. So I'll do that. Vim requirements YAML. Go down to the bottom. And I will cut and paste these two lines from here into this file. I'll save it and quit. And now I need to run the Ansible Galaxy install command to install those new requirements. So I'll go Ansible Galaxy install -y, oops, R requirements -p roles. So read the requirements file and install things into the roles directory. So run that. It's downloading the Cyverse Singularity role, and it downloaded the Golang role. And we'll just check to see if they're there. So cd into roles. And you can see here that we have Cyverse Ansible Singularity, and we have GAT-Sign Golang. All right, awesome. Let's move on. So now we need to tell our Ansible playbook which version of Singularity we want to install and where it can find Go. So we're going to install go to opt workspace-go, and we want to install the 3.7.4 version of Singularity. And we need to tell it where to find Go. So we're going to add these to our Galaxy servers to a YAML file in our group vars. Right, so we'll go vim group vars. Helps if I'm in the right directory. Right, from my Galaxy directory, I'm going to get the vim group vars galaxy servers.yaml. And hopefully this file is very familiar to you, and hopefully you've worked on it quite a bit in the original tutorial. All we're going to do is go all the way to the bottom and then add in this section here. Like that. So basically we're saying to Golang that we want to install it into /opt/workspace-go. And when we install Singularity, we want to install Singularity 3.7.4. You'll be able to find Go at this particular path here. All right, so we'll close that. And this variable here is set by the Go role, so that's fine. We'll close that. And now we need to add these two roles to our playbook. So we're going to do that. We'll open up our playbook and we'll add these two roles. One thing you will notice though is instead of adding them to the end, like we did during all the way through the Galaxy tutorial, in this case, we actually need to add them before Galaxy, because Galaxy is going to need to know about Singularity when we rerun the Galaxy role again. Okay, so we need to install Golang first, and then we'll install Singularity. And in this one, it's very important that we get the order correct. So we'll edit our playbook. vim Galaxy YAML, and we need to, in here, we need to put GAT-GCC.Golang, and then directly underneath that, we need to put Cyverse Ansible Singularity, just like that. Okay, so now these are complete. I'll save that, exit. So what did we change? Well, the first thing we did was we downloaded the new roles and we installed them. Then we added the variables required to set those roles up. So these variables here into our Galaxy servers.yaml group vars file. And now we've also added the two roles into our playbook so that when we run the playbook, it will know to run these two roles. And now the only thing left to do is to run the playbook, and then hopefully we'll have Singularity installed. So let's try. Ansible playbook, galaxy.yaml. Okay, and this will take a little while to run. Let's see here, it's going through the Postgres role, which we did in the previous tutorial, but now we're up to the bit where we're downloading and installing the Golang. Okay, so Golang's finished installing, and now we're installing Singularity. This may take some time. Okay, it looks like it's finished. And now it's going through the rest of the playbooks, or the rest of the roles in the playbook, which are the ones that have already been run. So hopefully there won't be too many changes or anything updated in this. So it's up to Galaxy. After it's got to do certbot and Nginx and all of those ones. And then it'll be complete. Okay, so our playbook is now finished running. You can see here that we had 14 changes, and most of them were the installation of Go and also the installation of Singularity. All right, so now we're going to test and make sure it works. And the way we're going to do that, well, actually, the first thing we're going to do is clear the screen, and then we're actually going to try and run Singularity. So if I just type Singularity here, you can see that something's installed and it comes up with its help text, which is wonderful. But now we're actually going to try and run a container. And the way we do that is we say Singularity run, and then we give it the name of the container. And this one, we're just going to try and run the Docker hello world container, which is a pretty standard container that we try and run all the time. All it does is print hello world to the screen. So let's try that. Singularity run Docker hello world. Okay, so it knows about it. It's getting the image source, it's downloaded it, and wonderful. It says, hello from Docker. This message shows your installation appears to be working correctly. Oh, that's pretty awesome. So that means we have installed Singularity, it can download containers, it can run them, and everything seems to be working, which is wonderful. All right. Now we're up to the step where we need to tell Galaxy about Singularity so that Galaxy can use it to resolve tools. So we can say, I need to run tool X, and so it knows where to go to look for the container for tool X and how to use it. Okay, so there's a whole bunch of different things we need to do. Every time we try and run a tool from Galaxy, it will try and fetch the container from biocontainers if it hasn't done already, which is pretty nice. That means we can just say, here, install all of these tools, and then the first time it goes to run them, it will download the appropriate container and use it. And once it's downloaded it once, it won't need to download it again. Or we can forcibly tell it to download containers before we run any of the tools. So what we're going to do now is we're just going to configure Galaxy so that it knows how to find containers. All right. So the first thing we're going to do is edit the Galaxy service.yaml file again. And we're going to add a dependency resolvers config file and a containers resolvers config file. All right. So let's edit that. Root files, Galaxy servers. We'll go all the way to the top. Okay, and it says in the Galaxy config, under Galaxy, add these two lines. We're going to add dependency resolvers config file, and it's going to be found in the Galaxy config directory, and it's going to be called dependency resolvers conf.xml. And then we're also going to add containers resolvers config file, the variable, and the file for that's going to be located also in the Galaxy config dir container resolvers conf.xml. All right. So let's do that. Cut. And then we will go to Galaxy. So directly under here, we'll paste those two lines in. All right. That's pretty cool. So now they're in the Galaxy configuration. So when we start Galaxy now, Galaxy will know where to find those two files. However, those two files don't exist yet on our machines, and we need to copy them to our computers. And just like all the other Galaxy config files, we've been using this Galaxy config templates directory to do that. So I'll go back to here. So where it says Galaxy config templates, we need to add in these 2 lines here underneath the ones that already exist. So I'll go down to here and paste that in. So basically we're saying copy another file out of our templates directory and put it into the correct position in Galaxy. And we're saying put it under the Galaxy containers resolvers config file place. All right. But now what we're going to do is we're going to also copy another configuration file, but this one isn't a template. This one is a static file. And so instead of using the templates, the Galaxy config templates command, we're going to use the Galaxy config files variable instead. So we're just going to copy these 3 lines from here. Yeah. And so you can see there's another variable here called Galaxy config files. It's set up very similarly to the way config templates are set up. We have a source for each file that we want to copy to our machine and a destination for that file. However, in this case, we're not adding the Ginger extension. And because it's a file, not a template, the file will be copied across exactly the way it is. When we copy across templates, it runs the Ginger stuff in the background and resolves all the variables that are inside the templates before it copies it across. However, in this case, it's a static file. We just want to copy it across. Right, so that's done. Save that and get out. Right, so we're going to be copying something out of templates. So if we go into templates and into Galaxy, and then into config, oh, hang on a minute, that container resolvers conf file doesn't actually exist there. So I guess we're going to have to create it. And we're also going to have to create, as you can see up here, there is no files. If we go back to here and have a look back in our group files, our Galaxy servers again. You can see here that where the source that we're looking for is for the template file. The new template is Galaxy config container resolvers conf. That doesn't exist yet. And we're also looking for files, Galaxy config dependency resolvers, conf.xml. But this whole directory doesn't exist yet. So we're going to need to create all of that. So let's get on with it. So we're going to create the files Galaxy config directory, which because it doesn't exist, so we're going to make it exist. Enter -p files Galaxy config. So now if we tree directory, you can see here that we have files Galaxy config, and we created that all with one command, make the -p. All right, let's have a look and see what we've got now. So files. All right. So now we want to actually create that file. We want to create a file Galaxy config dependency resolvers conf.xml. And so the easiest way to do that is to vim it, copy, vim, and paste. So vim files Galaxy config dependency resolvers conf.xml. And in that file, we are just going to put the following lines. Opening XML tag for dependency resolvers and a closing tag for dependency resolvers. And that's it. So basically, it's just an empty file. And this is so we can override Galaxy's defaults, because Galaxy will default to looking for Conda packages. Okay, and by making this blank, we're telling Galaxy to not use Conda or not use Galaxy packages or not use local tools at all. Try and resolve everything some other way. All right, so we're leaving this blank. We'll save that, or not blank. We're just having opening and closing tags with nothing in it. Normally, a dependency resolvers conf file has a list of the order in which we want to resolve dependencies, and later on in other tutorials, we'll be adding to this file. All right, so that one's done. And next it says that we need to create a template for container resolvers conf.xml.j2. And it's a template because it has variables in it. So we're going to create this file. And it goes in our templates directory. Right, then in this one, we're going to copy and paste this. So container resolvers, opening tag and closing tags, and then a bit of information that we'll talk about in a minute in here. Copy and paste. So we created a file called containers resolvers. Okay, so we've copied this in, and this basically just tells Galaxy where to find the Singularity containers. And we're going to put it in this Galaxy mutable data dir, and we're going to put it under cache and Singularity. And all of these directives here basically just tell Galaxy how to handle Singularity containers and where to find them. So we'll save that, quit. Okay. So what we've done so far is we've edited our Galaxy servers.yaml file, and we've changed some directives inside the Galaxy config to say, hey, there's a dependency resolvers file and there's a containers resolvers file, and they're located in different positions. We wrote the Ansible directives to copy those files and templates across. And then we created those two files. So we created a file and we created a template. So next, what we want to do is we want to edit our job.conf file. And remember from the previous tutorial, the job.conf file is very important. It's the file that tells Galaxy where to run jobs or how to configure its job handling. So we ask Galaxy to run a tool for us. So we load the tool form into our web page, we fill it in, we press the little blue execute button, and then Galaxy says, okay, someone's just asked me to run a tool. It then goes and looks through its job conf and says, okay, where and how do I run this tool? And what we're going to do here is we're going to set Galaxy to use Singularity for all of its jobs. And we're going to make it the default, and then we're going to create a runner, and I'll go through that as we do it. Right, so we want to edit our job.conf file, and it's in templates. So vim templates Galaxy config job.conf. And you can see here there's a couple of different sections. There's this plugins section at the top, and then there's this destinations section. So we want to add in a destination, a new destination for Singularity, and we want to make it the default. So we're going to edit this line here. We're not going to have local destination as the default destination anymore. We're going to have Singularity be our default destination. Okay, and then we're going to add in a new destination. So we're going to want to copy and paste all of this. Copy and paste. So we've created a new destination. It's called Singularity, which is good because that's our default one. The runner we're using is a local job runner, which means we're going to run things on the local machine. Now we're going to set some parameters, or I set a parameter for this destination. And the first one we're going to do is the ID, and it's called Singularity enabled is true. So for this destination, we want Singularity to be enabled, which is great because we want to use Singularity containers. Right, then we're going to set some environment variables. And the first one we're going to do is set this lc_all to be C. And this basically just means that we've got a consistent collation environment. And then we're going to set the Singularity cache dir to be /temp/singularity. So this will hold the Docker containers that get converted to Singularity containers. And then we will, we need a temporary directory to build the squashfs file system. And we're going to put that in the Singularity tempter, and we'll just put that in /temp. Okay, so they're the 3 environment variables we're setting as part of this destination. And we will, right, quit. And now we've done all of that configuration, we're going to run the playbook, and this will hopefully mean that Galaxy will then start using Singularity containers to run jobs. So first thing we did was we told Galaxy about the fact that we want it to use Singularity and that it needs to load some new configuration files. And then we created the configuration files and told Ansible where to copy them to. And then the last thing we did was we set up a job destination inside our job conf file, explaining to Galaxy how to actually go about using Singularity and where to store everything. Okay, so now all we need to do is run our playbook. So we will Ansible playbook, Galaxy YAML. All right, and this one won't take anywhere near as long as the last one, because all we're doing in this case is reconfiguring Galaxy. We're not actually installing Singularity or Golang or anything like that this time. So it should go much quicker. All right, so you can see here it's copied across the 2 new config files, the static one and the templates. It's rebuilt the galaxy.yaml file. And now it's just going through the rest of everything. Pretty soon it'll be finished. It will restart Galaxy for us, which is fantastic. All right. So Galaxy is now restarted. And if we want to, we can look at the journal to follow the Galaxy log. And you can see here that it's starting up, everything's getting ready to go. Okay, that's enough logs for a while. Here's the screen. But now hopefully Galaxy should be running. So let's go and check that. Here's my Galaxy server. I'll reload it just to make sure. Yep, it's running. Fantastic. Now we need to install a tool and then tell Galaxy to use it so that we can check to see if Galaxy is actually going to use the Singularity containers or not. In the background, while we're waiting for that to happen, I might just look at the Galaxy log. Journal CTL minus FU Galaxy. One thing to note is that if you're going to be the administrator of a Galaxy server, you will become very familiar with looking at these log files. Everything that Galaxy does is recorded in this log file, and it's a really good idea to understand what you're looking at, or even just to follow it along and look for keywords. Because sometimes things are obvious when things start to go wrong. It's all recorded in here, and it can also tell you what to do. But in our case, we're going to monitor it to see if we're actually using Singularity or not. All right, so we'll go back to our tutorial. And we need to now, it says, please install the Minimap 2 tool. So we need to log in as the admin user. Hopefully you made yourself an admin user in the previous tutorial. I've logged into this, my Galaxy server here. I know I'm admin because I can see this admin menu command here. I'm going to click on that. It will open up the admin menu for me, and then I need to install a tool. And the way I do that is under this tool management section, there's one that says install and uninstall. I'm going to click on that. And it says we need to install minimap 2. Okay. The way we do that is we just search for it. Minimap 2. Enter. All right, there it is. So I'm going to click on it. And I'm going to install the latest version, which is this one here, version 12. Click on install. And now it says I need to give it a section. Well, I know Minimap is a mapper, so it does small read alignment. So I'm going to install it into a section called mapping. Even if it doesn't exist, it'll create it for me. All right. You can see here now, it's cloning the repository out of the Galaxy Toolshed. And it's installed. Fantastic. So if we go back to analyze data here, we have a new section down the bottom called mapping. If I click on that, you can see here the tool map with Minimap 2 is installed. And if I click on that, you can see here we have the tool form for that tool with its user guide, citation, etc., etc. all in there. Pretty cool. All right, what does it say to do next? All right, so we're going to test the tool and we're going to upload this pretend FastA file and we're going to map it against itself, which is not something you would normally do, but we were basically just making sure that things work. So I'm going to copy this and I'll upload it as a file to my Galaxy server using the upload tool. Upload, paste, fetch data, paste, and then change the type to FastA. And start. Okay, so here we go. I've just uploaded this file to my Galaxy history. And now I want to run the Minimap 2 on that particular file twice. So I'm going to map with Minimap 2. All right, go here, map with Minimap 2. And it says to use a genome from history and build the index. And we want to use the FastA file we just uploaded, and we're going to do single-ended reads and the FastA file we just uploaded. So we're going to map it to itself. It doesn't matter, we just want to run the tool. So use a genome from history, pasted entry is all we want, single pasted entry, and then we're going to click execute. And as soon as we click execute, we're going to start monitoring this to see what it says. Okay, so we're executing, we're running this job, and you can see here, it's mapped it to Singularity. Map the job to destination Singularity up here. And you can see here, it's looking in bio containers for that tool. So now what it's doing, this Galaxy says, all right, I need to run Minimap. I need to find the tool, obviously. And so it's looked in its tool resolvers, the containers resolvers, and it says, oh, I've got to use Singularity here. All right, well, I get all my Singularity containers from biocontainers. So I'm going to go and get the container for Minimap 2. I'm going to download it. I'm going to run it using my input data. And you can see here it's finished and it produced a BAM file. This BAM file will be incredibly simple. It has one line and it's got amazing mapping. There you go. So we've just installed Singularity into our Galaxy server. We've told it to install a tool. We tried to run the tool. When we went to run it, Galaxy realized it didn't have that particular container it needed. It went to biocontainers, downloaded it, and then started using it straight away. And now this container will actually be here. So if we rerun this job, it won't actually have to go and download it again because it will be in the cache. And it should be really quick. And it's done. So this time it didn't have to go and get the container. It was already in the cache. Okay, and there's a little bit here on managing dependencies. You probably noticed that when we ran this Minimap 2, the first time we ran it, it went looking for it. Right? It couldn't find it, and so it downloaded it. Now, you may not want to do that all the time, especially if you've got a lot of users using it. You may just want to already have it installed. And so you can do that. And the way you do it is you go to the Manage Dependencies section and select the Containers tab. And so we'll do that. We'll go to Admin. We'll go to Manage Dependencies. We'll go to the Containers. And once it loads, it should show us that we've got our container loaded. Okay, it's finished. I'm just going to look for Minimap. You can see here, here's the tool that we installed for Minimap. You can see here it's been resolved by Singularity. And if you look across, you can see the name of the Singularity container is this mold container, because this container actually contains two tools. We use Minimap 2, and we also use SAM tools. And the reason we use SAM tools is because the resulting BAM file automatically gets indexed by Galaxy. And so we need the SAM tools tool as well. And it all gets merged into the same container. All right. And that is the end of the tutorial. So if you missed any steps, you got lost along the way, you can compare your files against the reference files by clicking here, or you can see what changed from the previous tutorial. So you can see what changes we made from the last one. If I click on this, it will take us to this thing here, and you can see, probably can't see because it's very small, but I'll make it bigger. You can see here, these are the changes that were made to all the files. So we created a file, files, Galaxy config dependency resolvers, and we put these opening and closing tags in our galaxy.yaml, our playbook. We added the two roles. In our Galaxy servers, we added a bunch of stuff. We added these two variables here about where to, so Galaxy knows where to find those files. We told Ansible how to copy them across. And we also added some variables for Go and Singularity. We added the two roles to our requirements file, and we created our container resolvers, and then we updated our job conf file. So our default destination was Singularity, and we added in the Singularity destination here. All right, so I'll go back. Yeah, if you enjoyed this tutorial, please click on this link here and fill in the feedback form. And if you use this tutorial and wish to cite it and use it to build your system and you want to cite it, then these are the citations for this particular tutorial. And thank you very much for your attention. Goodbye.